Good morning. My name is Rodrigo. I'm the Zbus author and maintainer. Right today, I'm going to present to you a regular presentation I do usually. I did the first one in Prague and then Seattle, and this year here. I'd like to do that America Europe thing because to be in the both is not so easy. A long flight to be here. And so let's talk about Zbus, right? At the very beginning, when I start using RTOSes and Zephyr, in fact, I would like to make thread talks, right? It's usual. Well, everyone that comes from bare metal to RTOSes would like to make threads talk. It's the regular way to do, right? And we have a lot of mechanisms that can help us. And for example, FIFO, LIFO, message queue stacks, and a lot of things. And those fits well for one-to-one, right? That's okay. So you have a lot of options, and that's good. But when you want to have one-to-many, if you want something simple or at least straightforward to do, you don't have that, right? It's not so easy. You can, for example, if you want to have something from thread A to B, C, and D, you need to have at least one message queue per each. If you want to do that in both directions, you need to have two message queues per each to one direction and another, and that become a nightmare quickly, easy, right? So sometimes if you want to use mailbox, maybe with an extra effort, you can do that. But it's not so easy and not directly, it's not there for you, right? You need to do that by yourself. And if you want to talk many to many, we are going crazy, right? We are, I don't know, how many message queues, FIFO, LIFO, you are going to have a lot of trouble. And when we are doing things like that, other than having a lot of message queues or other mechanisms there, you are going to couple your unities on your code, right? You have a thread B knowing thread C, and if you change something on thread C or maybe one channel there or one communication, you are going to have a lot of trouble to maintain your code. That's bad, right? And we had a lot of that kind of thing here, not so, I don't know, a graphic complete, but you usually have one-to-many and many-to-many communications sometimes, right? And to do that with, if we cannot do it for one-to-many, you can imagine many-to-many, right? And to solve that in other full-feature OSs like Linux, Mac OS, Windows, usually we do a bus, right? We have a software bus that make a kind of layer between the entities that talks through the bus, and you can do or almost all the communication topologies we talked before, right? So based on that knowledge, I saw that working pretty well on Dbus, Linux, and other possibilities like macOS as well. Bonjour, I guess, I don't remember, but I created at that time Zbus. Zbus is part of my PhD, but I started working on that, I don't know, 3 or 4 years prior to the submission to the community. I was doing that to solve our internal problems. I'm RD leader on an innovation center inside the university in Brazil. So there we had a lot of issues and headaches on this kind of thing, and we were trying to solve that. And Zbus was a result of it. But when I brought that to the community, I had a lot of feedback, and we improved that even more, right? And that's the beauty of open source, right? And this is the current Zbus picture. That is the overview of it, right? We have a bus, we have a set of channels. Those channels are kind of, it's a shared memory. We use shared memory approach to store messages. So we have the message stored there. So when you publish to a channel, the channel will store the latest message you send through that, okay? That's the way to do, and that's the fastest thing. And one of the things that I would like to share with you, when I started Zbus, I was not trying to mimic Dbus. Dbus I was an inspiration, but not the goal, right? So I'm going to do another talk after the lunch, if you want to go there as well, and I am going to share with you the survey I did. And there we can see some people talking about Zbus, but we are not talking about Zbus. Zbus was made for embedded systems with embedded constraints and limitations in mind, okay? This is a from scratch solution, I could say, okay? So here we have channels, we have messages, and we have observers, right? If you take a look at the arrows here, when you have an arrow point to a channel, you are publishing to a channel. When you have a arrow coming from out of a channel to another entity, that entity is observing the channel. So that's a kind of diagram I created. I don't know. It's a simple one, but that shows you the event path, something like this, right? So at this very moment, we have here a sensor thread, which is a subscriber. We have a core thread and a LoRa thread. Both are message subscriber. The difference between them is the subscriber just receives a notification of a change, not the message. And the message subscriber receives a couple of a message. So that's a difference. And we are going to talk more about software engineering things here. And we have here the blink. The blink one is a listener. The listener was designed to be fast, lean, and clear, and objective, like an ISR interrupt routine, right? We need to do that quick and simple and fast as possible, right? Something like this. And the timer here is just an interrupt I'm showing. So in this scenario here, we have, for example, a timer that triggers every 1 minute, and that triggers through the trigger channel. And as the sensor thread is observing the trigger channel, it receives a notification, and that starts reading some sensor, get that data, and sends to the sensor data, right? So the sensor data, as core thread is observing the sensor data, it will receive a notification, get the sensor data, do some fusion, some calculations on that, some math on that, and send and publish that to the payload. So in this case, we have a LoRa thread that can receive the payload and process that and send to the cloud. Once that is confirmed or not with error, you can do a transmission done with the code saying that's okay or not, something like this. And if you take a look here, all the threads are working based on channel, not based on other threads. So if we are going to look at closer, we can see several kinds of decoupling. We have decoupling in space, time, and synchronization. In this case here, the subscribers and message subscribers, they are space and time and synchronization. Space, which means they don't need to know the producer. The consumer doesn't need to know the producer. Time is the producer and consumer doesn't need to communicate at the same time. The communication can be asynchronous. And the synchronization means that the consumer and producer can do different kind of things other than the communication process. So you can do different workloads and you can receive a notification parallel or asynchronous. You can do a lot of things, right? So it's modular. That gives us the possibility to do modular things and flexible as well. And the listener are just space coupling, the coupling, sorry, because they need to work on the time of the communication. So they are callbacks, almost callbacks, and they cannot run different kind of things because they just run when I publish to a channel. So that's it. But even just the space coupling is amazing because the listener doesn't need to know the consumer doesn't need to know the publisher, okay? And so for the introduction, we have motivations, and just like to point out that Zbus promotes modularity, flexibility, and reuse. That was the goal since the beginning, and that's delivered on that bus. Okay, so the contributions since my last talk in Seattle was 23 pull requests merged. Among them, we have 4 new features and some bug fixes and other things. I'm going to mention you about the new features, and just you to see. But I'm really glad and thank you communities to start contributing more to the Zbus. My last talk, I think it was 1 or 2. Jordan is over there. Thank you. And now we can see more people, and I'm really glad to see that. I hope the next event I cannot share one single slide. I need to do 3 or 4. Let's see. But thank you. So another great news is Zbus is stable right now. What does it mean, right? No drastic changes. So if you are thinking in use Zbus, but you are not so, I don't know if it will change a lot. It will not change a lot. The APIs, so the Zbus will not disappear tomorrow from Zbus or from Zephyr. So it is attached, and I believe that we are going to integrate even more with other subsystems and other aspects of the system, in fact. And all new features now need to have compatibility, backward compatibility, which is amazing. And if we are going to remove something, we need to deprecate that and stay at least 2 releases to remove. So you have time to, no? Well, okay, you have time to change that. So at least 6 months or so to change your code base, okay? So about new features, at the last presentation, I was talking about message subscribers, which is a quote, new kind of observer, right? It receives messages, but all the message subscribers share the same pool at that moment. So we have a big pool of net buffers, and every copy of the message would be accompanied, would followed by a net buffer. So you have a big pool. Every time you want to send a message, you need to get one buffer from that pool and send. So it was just one big pool for all the net buffers. So, but sometimes you need to ensure the communication between 2 channels. For example, you have two entities, 2 threads, critical threads, and you need to ensure that it will work differently from the other parts of the system. Sometimes you have some parts that are not so important. If you lost some communication or some deadline, it's not a big deal. But when you have some critical path, you need to ensure that it work, right? And on that scenario, now we can separate, isolate some pool for that. So you can have a pool for net buffers for just a set of channels. So you can separate. You have a big one for the whole system, and for the set of special threads or critical path or something like this, you can separate, right? That's a good thing for mainly for for whom is trying to do. It's kind of safe thing. The channel unique numeric identification. This is Jordan's. It's a great thing to integrating Zbus to external tools, or when you don't know exactly the reference of the channel, because when we are talking about channels in the code, we are talking using reference, right? We have a reference name and we use that a lot, or external and declaring channels along the system. But with this, we can use numeric IDs, so you can do that, and it can help you to make some tools or code generation and mood core. It helps you a lot when you are trying to make external things, not just in the same core code, right? So you can define like this, channel define with ID. You pass the ID. The ID is a number, right? 32 number, 32-bit number. And when you want to get the channel back, you just need to pass that number, not the name. And that gives you more flexibility to adapt certain scenarios. Okay. Another thing is channel publishing statistics. We have basic statistics for channel publishing. When we can collect that, you enable that feature. All those features here are optional, right? So you need to enable that to make that work. And in that case here, we can see how many times that channel was published, for example. You can see what the latest time was published and the average period between publishing actions. Okay, so that's the basic thing that's working. We are planning to increase that and do different kind of statistics. But I was imagining to do that outside, not inside. But we are going to discuss that more on Zbus 2030, the next presentation. Okay. Runtime observer pool. At first, we relied on the heap. So all the runtime nodes were allocated on the heap, and that generated a lot of discussion on the community. And now we have that behavior, the previous behavior. We kept that. So we have the default. We don't need to change anything on your code, but it's using heap. If you want to do that in a static way, you can use runtime observer pool. So like the message subscriber pool, you can have a runtime observer pool, which will help you, and you can do that statically. Or if you don't want to have that either static or heap, you can do by yourself, allocating individual nodes. Like, for example, if you go to the GPIO API, you need to have a callback, for example. The callback, you need to create the callback, and then you need to add that to interrupt on some GPIO, right? It's similar to that. So we have dynamic, static, and no allocation, almost something like this. Okay, so this is one of the things I am planning to do in other parts of Zbus, right? This is possible. Dynamic, static, and no allocation. So in summary, we just have those. I didn't have so much time to work on Zbus. I had twins, right? and that was and my oldest boy has 3 years old. Is turned 3 years old. So I have 3 children less than 3. So it's a challenge. So my spare time is shortened right now. But I'm planning to do some changes, and there are more people helping me on that, and I believe that we can keep going pretty fast on that. Okay, so a little bit about the roadmap. When we talk about Zbus, one of the things that we face internally, and I talked to other companies, were listeners. When you have listeners and you want to publish from an ISR, you are going to run all the listeners. So that can increase a lot the ISR latency. So if you have, for example, 2 or 3 listeners, and you have that, for example, at that sample, we have a timer publishing to trigger. If you do that all the time, you are going to increase the interrupt latency for that channel all the time, which is not so good, right? And for solving that, I'm developing a new async listener. It's a listener, but it's not running on the publisher context. It's running on a work queue context, which you can pick if you want to use the system work queue or a separated work queue, and you can do that to save memory, for example. Instead, you have a lot of threads doing things on channels. You can using a work queue, right? They are still fast, right? The system work queue, for example, we have there a cooperative thread. Usually, by default, it's -1 priority, so it's cooperative. It will work. It will consume the data before the other observers, which is expected for a listener. We still know that their behavior in definition at the definition time, which is the listener. The difference between a listener and a subscriber is that. And someone asked why I am using different kind of terms when we are talking pub sub, right? But here we are not talking about topics because we are not MQTT and we are not string based. We are channel based. We are doing pub sub. Technically, we are doing the same thing, but we are not talking about the same thing. So, to be more generic, I call observer the entity that observes a channel. But the observers, we have listeners and subscribers. Listeners are that kind of things that you know the behavior. When you define that, you have a callback explicitly doing that. And the subscribers just receive the message and you don't know what they do with that, right? So this kind of thing, they are slightly different. With async listeners, we can run heavy loads, or I don't know, we can decrease ISR latency, right? Because you can put something to run on the work queue without doing extra effort. We can do that right now using listeners, but all inside the listener, you need to call a work queue and do a pending work there, and that will work on the sometime after. And another thing that is pretty important, and you see that a lot on Bluetooth or other kind of samples that needs to consume few RAM, we have a kind of interfaces that can run a work queue, right? You have a behavior, a service behavior or some entity behavior that is running on a thread, but it's not its own thread. So you don't need to have a thread per service. You can have just interfaces and the behavior is defined, and you can run that behavior in a single work queue context. So that can gives you more space to grow because you don't need to have, for example, if you have 10 services and you need to, for example, define behavior inside those services, you need to have 10 threads, each thread with its stack, and that could be I don't know, it will consume a lot of stack, right? And that can help people with that. I'm calling that service because we usually call that service, but there are modules or high-level drivers, the drivers that expose interfaces on Zbus, not as a regular CAPI. So that's what we are calling high-level drivers, right? And you can call whatever. So this is pretty close to the listener callback. It's almost the same thing, but here is the difference. We receive a copy of the message. The regular listener is running on the publisher context, so that the channel is locked. So you can access the message without having issues. But here, we are not during the process. We are after the notification process. So we need to ensure that the message is consistent and there, and we send a copy. It's similar to the message subscriber thing, okay? And the definition is pretty similar. Just add async here, and we are going to have an API to set a different kind of work queue. If you don't want to use the system work queue, you can set a different work queue, but the basic will be using the system work queue, the default implementation, right? Another thing that we are working on, I'm not implementing directly, but there is a team on Nordic doing. We discussed a lot about multi-core and multi-target scenario. That is a challenging thing for Zephyr and Zephyr Linux thing, right? we need to run several cores on this, and those cores need to talk each other. Usually we use OpenAMP or ARP message and do a lot of things. But the intent here is to have Zbuses across the cores, and you can pick some of the channels to be synchronized on the other cores. So we started thinking to have a two-way communication from one core to another, but it's pretty hard to have. So we came up with the idea of a shadow channel. The shadow channel is a copy or a reflection of the original channel. In this scenario here, I don't know if you remember, but we had trigger, sensor data, transmission done, and payload thing, right? We are separating two cores. It's in the same SoC, but they are in different cores. And in this case, we have a prox agent that's responsible for communicating between those cores. But for example, that's okay. Keep going. And here, for example, when we receive the sensor data notification, we publish the core thread published to the payload one. So once that published to the payload, the prox agent knows about that and sends that to the other prox agent, and the prox agent published to the payload here. So the payload in the right side of the image is a read-only channel. It's a shadow channel that it just reflects what is in the other core. But it's a seamless integration. You can just use as a regular. You cannot just publish to it, just that. So we are going to have a lot of this kind of thing, but all the complexity is in the prox agent part, and we are solving both mood core and mood target at the same time by just changing the medium of the communication. If you are talking about cores, we are talking about RP message. If we are talking about SoCs, we are talking, I don't know, we are discussing about UART or, I don't know, USB or something like this, right? So if we have APIs on the prox agent that can abstract the medium, the communication medium, we are solving both of the problem at the same time. And we can do a lot of great stuff there, mainly if you, I don't know, as a semiconductor company, if you have 4 cores thing that asynchronous, that you have some things to make them work. And usually we have a just one-way communication between the cores, usually. If you need to do both way, you need to have 2 channels, just that, one RX and another TX or something like this. Okay, the code's available here. The presentation is available on the SCAD. If you want to have all the links are there. If you want to have that, you can just download that and follow the links, okay? Another thing is about tooling. There is a friend of mine, Paulo. He's working on a tool called Zview, but he's trying to change the name because Zview, there is another thing called Zview, and he's trying to collect information from the core without programming or changing the code. By just look at the ALF file, it uses JLink to read memory directly. Hot MCU, read the memory, and on hot MCU, and he could do this kind of thing here. It's working. So we can have the statistic about stacks by not doing anything. That's just enabling and using that outside. And that is one of the things that we are doing there. This is running inside the Innovation Center. We are doing that there. And the next step here is to add messages to it. So you can see the messages changing and you can follow that. My goal, my view on that is something like this. I don't know if you are used to, it's a waveform, but I would like to see a kind of message changing along the time, so you can see the changes, and maybe you can see who changed that. Maybe that we are trying to work that. I call that Zview++, right? But that's the goal I know it will be very different from it, but we can I don't know, we can define the message like a proto buffer or something to show the actual value here. We have I don't know, an array of bytes, but here, as we are using proto buffer or something, we can see the actual information, and you can see things changing. I loved that when I use Verilog, VHDL, and things like this in the past, but I was missing something like this. And with ZView, we can do that in a non-intrusive way. So we don't need to change anything in the code, and maybe we can run using the production-ready code. That's the beauty of that. Okay, and this is in the way. Another initiative we are working on, it's you see that I have a lot of things to do, but there are another leader that's not me. That was the goal, right? I have other person working with me, doing great stuff, and I'm just by the side. It's good. Oh, I don't know, and you can give people power to innovate and bring things. And that's, I think that's the way to build a big community and a better community. And he's another friend. We call him Moeda. It's a nickname. It's coin, like something like this. And we are working together with the Madrid, one of the universities in Spain. We are trying to make a kind of Lua port to Zephyr. That already happened more than once, but here we are planning a minimal bind set. That's the one of the goal we have there, because if we just have the minimal bind set, we just have a really thin layer on top of that, and you can run Lua. And I don't know if you know Lua, but that has a brilliant integration with C, so it's pretty easy to integrate with C. And it's not heavy. So if you compare that with MicroPython, JS, or something, it's pretty lighter. And that can give you the possibility to make a firmware update without needing to rewrite all the firmware. You just need to send another file, right? That's another thing that we are trying to achieve here. And maybe if that is working, it's work okay, we are trying to do another languages. Maybe Objective-C, maybe Nin. I don't know if you know about that, but it's a good. There is a good integration with C as well. So we are trying different kind of flavors here, because the mission is to make the developer life easier, not just Zbus, right? At the beginning, and Zbus is part of that, right? So. Since we just have a minimal bind set, like for example sleep and log, we just need to know Zbus interfaces to interact with the rest of the system, because all the C dependent code is written above a Zbus interface. So the rest of things we can access through Zbus, and maybe you can simulate everything. You can simulate and emulate everything by just using channels. And that's a pretty straightforward way to keep going. Okay. And the latest one, it was an idea that happened during the event. Some cores nowadays have a Linux core and a real-time core, right? It's usual. And how can we integrate both in an easy way? You can do, I don't know, different kind of integrations by OpenMP and things complex. But here, the idea is to have a Zbus for Linux that is very good for testing, right? You can write things on the Linux side and integrate with Zbus. Since we have the mood target working here, we could have a Python script publishing to a Zbus channel, and this channel is being replicated in the embedded, and you can do crazy things with that, right? And that enables us to make a really, I don't know, a really fast test bench, for example. You can do a lot of things with it, right? And if you want to do that in an application running Linux, maybe if we can integrate Zbus with Dbus, we can do a regular Linux application talk to a Zephyr application directly through their Zbus, the buses. Okay, so the Linux application will use the same interface or same bus as usual, and the application side, the embedded side, will use the same bus as usual. So native or natural for both sides. That's the goal here, right? And that's that's not so. It's an idea, and we are going to work on that. I think it's a long-term thing to have. Okay. So the summary here: async listeners. We have mood core. We are doing async listeners. We are doing mood core and mood target. We are doing the tooling with the view. We are doing Lua Zephyr integration, and Zbus for Linux is a plan, a dream. Okay. And that's the presentation summary. We talked about motivation, Zbus, new features, and roadmap. And that's the QA time. Okay. Any questions? Thank you.
Hi. So could you expand some more upon the Lua options when talking through Zbus to Zephyr, as I understand it, right?
Yes, yes. The idea here is to all the hardware dependent things should be implemented in C, right? For example, LED driver, network, maybe network we can integrate to Lua, but if you have a modem, if you have different kind of things, you could do that in C. You have a thin layer on using Zbus, and Lua just talk through Zbus. So Lua just need to know Zbus to use the rest of the system.
Okay, that may be an offshoot question, but I happened to tinker with Lua some time ago. And would you then be also like contributing to Lua itself if need be?
Yes and not. They are pretty stable right now. They are in the 5.4.7, 547, and they are pretty stable. And they are. It's a really short and lean language. I believe that would not be necessary, just that module, and that would be an external Zephyr module. You can just use that on your manifest and use that directly.
Hi. Hi.
Yes.
Yeah, nice. So, thanks for the talk. You mentioned support for multi-core Zbus.
Yes.
Will it be possible to talk to multiple cores at once? So, for example, having observers distributed over multiple cores, and if yes, how do you maintain cache coherence or coherence in general?
We are in the first phase of implementation, right? We are focusing on 2 cores yet. We are going to see and face some issues in the way, and interactively in some iteration change things. But I know that there are a lot of challenges on that. This is why we chose to just do a one-way communication. You see, it's just one way, and you just need to send from one core to the others, not changing and going and back and forth. You see, we are trying to avoid the several issues in that approach. Okay.
Is your plan to build the multi-core or dbus support on top of OpenAMP, or is it planned to build your own remote processor messaging?
No, open RP message, in fact.
Okay.
Based on that. Not reinvent it. Well, just Zbus was the thing. The rest we are trying to use almost what's there. Okay.
Okay.
So I learned this week about RTIO as
Yes.
another bus for high throughput data, and then Zbus is this generic for low latency. Are there any integrations, or is there any way to one wrapper use the other or association?
A good question. Not yet. Zbus is now it's mainly for application development. I would like to see Zbus integrated to other modules. I'm planning to offer that as an option. For example, if you have Wi-Fi scanning, you could receive that scanning on Zbus channels instead of having a callback, and things like this. So RTIO and other subsystems would be better integrated to Zbus. Since now we are stable, we can think of that. You see, because before we were not stable, and when once I say no, let's integrate. No, I don't know, and tomorrow maybe, and thing like this. We are stable. A lot of people is using that, and maybe it's time to integrate to other parts of the system. Okay.
So building upon that, and perhaps a generic question towards Zbus and using Zbus as the Lua integration kind of middleware or frame buffer for communicating up there. What are the concerns in terms of real-time performance when you put Zbus in the loop?
Real-time performances?
So for instance, if you want to integrate Lua and run some network task in there, then you have the Zbus, which is async, going upwards, and
yeah. If you can choose what you want to do in Lua. For example, maybe if your application just need to know, for example, if you just need to be synchronous, and we can do whatever you want in Lua. The Lua part is just to make that enable to develop new things. You see, let's say a flexible way. But if you want to do that asynchronously, you can have different kind of channels, and that is running on a Zephyr thread, in fact. So that has that's, for example, sleeps and all the things. The Lua thread will work as a regular thread. So once the payloads, I don't know, sent to the internet, you can publish again to the Zbus. I don't know if I was clear or if I understood well the question, but it's just you are doing that asynchronously. The response will be asynchronous. So the entity in C just need to be ready to receive that asynchronous answers. Is that clear? Okay.
Hey, about the async listeners, did you already think about like a way to kind of prioritize them themselves? Because now, if you would add them all up and we would end into a work queue, it's a bit, let's say, tricky to say when it will be executed.
That's one idea. We do that for all the other listeners. All the other subscribers, observers. That will be kept here. Thank you, and thank you. He's one of the most. Tobias was one of the most active persons in Discord on Zbus. Thank you very much.
I don't know if I've perhaps missed it, but for the async listeners, what will you also have an option of specifying the memory pool to use to keep the data before it's put onto the work queue?
You're going to have the same thing that we have on message subscribers. It's almost the same. You see, I was trying to separate. Maybe I'm going to use the same pool. I don't know. We need to. I have a implementation of it. It's working. Just SMP problems. I'm facing some problems on the test CI, but it's working there. One option is to separate, but you are going to have one more pool to manage, and maybe it's not a good way.
In a in a similar vein, why are the async listeners copying data in the first place as opposed to just locking the channel when they run? Because they're scheduled immediately, right?
Yes, but I don't know, maybe your application has some cooperative things that has more priority than the system work queue or some work queue, and you are going to see some loss, some message loss or repetitions, as we have on subscribers. You see? Maybe that's possible.
Cheers.
Thank you. I think, oh, sorry, the latest one. Well, okay, let's keep going.
In terms of names of channels and channel IDs, they are all under my control, or is there some predefined channel numbers?
You can do whatever you want for the naming things. We have a naming convention, not a name convention. We are about to create a name convention, but we usually use prefixes or suffixes for channels, observers, and things like this. But you can pick the name. It's flexible.